obviously fluids, temperatures, pressures are important, but even things as minor as the surface finish of the surface the seal will work against, the material that it's sealing against, each of those parameters can have an impact on the seal life, and the more information that's understood about the system as a whole, maybe surprisingly, really can affect what type of design and solution.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Jeremy Black, design and analysis engineer, sealing systems at Greene Tweed. He's going to be speaking with us about sealing in high pressure, high temperature environments. So without any further ado, let's get into the episode. So welcome to the Pumps and Systems podcast. We really appreciate you being here. How are you doing today?
I'm good. Thank you for having me.
Sure. So before we get into our main topic, would you mind introducing yourself? So tell us a little about who you are, what you do, anything you'd like to share with us.
Well, my name's Jeremy Black. I'm an applications engineer with Greene Tweed. I've worked at Greene Tweed, supporting our sealing systems product line for around 4 years. As a company, we serve a variety of industries, semiconductor, oil and gas, aerospace, defense, chemical, pharmaceutical processing, and other industries. We've been doing that for over 160 years.
That's a lot of years.
Yeah. And, during my time here, I've gotten to work with a variety of those customers and industries. And prior to working at Greene Tweed, I worked extensively to design and test valves, seals, and other pressure vessels.
Great. Okay. So moving into our main topic. So we always like to start with kind of the absolute basics. So can you tell us what exactly is an HPHT environment? What does that mean? What's kind of the 101 of that?
So, as the name suggests, high pressure and high temperature are extreme. So there's a lot of challenges for all sorts of aspects of the equipment, especially the seals, because they're the most critical component. So, in those applications, you can see things with the seals related to chemical degradation, creep, extrusion-related failures, rapid gas decompression, and even just overall long-term compression set of the seal, which all of those things contribute to make up how you would judge the seal's performance. What's really tricky about these environments is that they can change rapidly, and oftentimes when working with customers, we find that they've been slowly, minorly changing and seeing those pressures and temperatures creep up over time as their needs change, and the seals just all of a sudden stop working when they were working fine previously.
So you touched on this a little, but what is it that makes HPHT environments so challenging for sealing systems?
When you get into aspects of seal failure, every seal is inevitably going to succumb to compression set, which just means the seal takes on a permanent deformed state and no longer can react elastically to the pressures and temperatures it's operating under. You can also see other elements of the seal succumb to creep or nibbling or extrusion, which is just long-term degradation over time. When you're working at higher temperatures, higher pressures, these things happen more rapidly than maybe at lower pressures and temperatures. And obviously, when the seals fail, it's not good. It can, in a dramatic sense, lead to plant shutdowns or process shutdowns, safety issues, even regulatory emissions problems. So, seal reliability is a really critical part of any system's performance.
So we know that HPHT environments can accelerate seal failure. So can you walk us through kind of why that happens and maybe tell us about some of the most common failure mechanisms?
Yeah, most commonly you'll see, like I was saying, compression set, creep, extrusion, basically just how does that temperature play a role in the performance of the materials in the seal over time. Specifically, fluid compatibility can be a big problem. You have certain thresholds of temperature you cross, the performance can, be reduced dramatically.
Material selection is a big factor in designing seals for extreme environments. So what material properties do you think are the most critical for these kinds of HPHT applications?
So for material properties that are critical, fluid compatibility is one of the most important. The wrong elastomer will degrade incredibly quickly. Again, as I keep reiterating, you want high strength backing elements in your seal design that are designed for those conditions. And then also just thermal stability of the materials to prevent their degradation over time.
Beyond materials, seal geometry and mechanical design also play a big role in performance. So how should someone approach balancing material selection with design, specifically when they're wanting like long-term reliability under extreme pressures and temperatures?
When we work with customers on new designs, we take a holistic view of the seal and each element involved in it. We use pretty general requirements as far as fluid compatibility goes, but when we really get into the nitty-gritty is looking at how to take a standardized design and optimize it for performance in a system. And by doing that, we can affect the long-term reliability pretty significantly. So things that we look at optimizing in the seal design are the compression of the seal, which we call the squeeze, the gland fill, which is how are those materials expanding in that gland as temperatures applied. We also look at shear strength. We try to balance creep resistance, but that's a little tricky without real firm test data. But it's kind of juggling all those parameters to come up with the right solution.
So seals are often seen as individual components, but why do you think it's important to evaluate them in the context of the entire system?
It's a really important thing when we work on these customized solutions. Obviously, fluids, temperatures, pressures are important, but even things as minor as the surface finish of the surface the seal will work against, the material that it's sealing against. Each of those parameters can have an impact on the seal life, and the more information that's understood about the system as a whole, maybe surprisingly, really can affect what type of design and solution. I've seen customers in the past have a process they're running. This was with a V-ring valve packing, needed to modify the geometry, but the biggest change was the temperatures had gone from 450 Fahrenheit to upwards of 600, and everything they were using was melting. So it was important to work that through that. Were obviously a really critical process running at those temperatures, just to make sure that, okay, we're going to change materials, we're going to change geometries, don't want some other thing that was working fine to start being a problem when we fix why was the seal melting.
Right, that makes sense. So, in industries like energy and chemical processing, there's a trend of pushing equipment to operate in higher pressures and temperatures. So, how do you see sealing design and material science evolving to meet those sorts of demands?
Yeah, for the industry as a whole, sealing technology has come a long way. Things started as O-rings, have evolved to T-seals, and now FFKM and peak materials that are the cutting edge of thermoplastic and elastomer design. With that evolution, that's gone with the industry, but oftentimes we have to take a holistic look as a company at what the market's doing, where the market's going. One of those examples, we've done extensive work to validate one of our materials for use in ethylene oxide, which took a long time to test because we couldn't find a test lab willing to test such a nasty chemical. So we like to partner with both the industry as a whole and customers to keep an eye to where things are going, where things need to go, and we can take learnings from different segments and apply them across different applications. Because in some sense, high temperature and high pressure are universal ideas.
Next, let's talk a little about predictive maintenance and digital tools. So, how do you see those technologies influencing the way seals are monitored and maintained, especially in HPHT systems?
I think the biggest impact of predictive maintenance is there's just more granular performance data that directly highlights what the system needs to keep functioning as long as possible and reliably as possible. And I think ultimately the seal is often the weak link in that equation. And as the maintenance and digital tools, improve and there's more perspective, there's naturally going to be a, well, how do we get more life out of this system? Well, it's going to come back to how those seals work and function and continue to evolve.
And is there any advice that you would give to maintenance engineers who are working with HPHT systems?
The biggest advice I would give is something that I see as a seal designer is that we frequently find customers and engineers trying to solve it themselves. And so, what I would tell those engineers is don't try to do it alone. There's likely a right material and a right seal out there. You just don't know about it yet. And yeah, don't be afraid to ask for help.
And do you have any stories or personal anecdotes you'd like to share with us about your experiences with HPHT?
Yeah, there's an example I have with a high temperature pump manufacturer. We had to go back and forth several times, sort of fine tuning the application requirements, just to highlight kind of the minimal changes in variables we're talking about it. In this application, they were seeing a mix of steam and petroleum-based fluids and, elevated temperatures. And we kind of went back and forth with them on the material selection. I think the temperature range was changing maybe 50 degrees Fahrenheit, and that was heavily impactful on the seal design. We were going two completely different options just based on that alone, and then based on the usage of steam there and that combination of temperature. So I think they knew what they were getting into, but I've had other situations where customer doesn't quite know what they're getting into and the seal's suddenly a problem, and it's something as fine as like 50 degrees is enough to swing the entire system function enough to impact the seal from working to not working.
Yeah, so what do you do in that kind of situation where the person on the other end doesn't really understand?
Yeah, the approach we take, which I really like a lot, is there's a lot of seals that work and work in practice, but maybe when you take a closer look and do the analysis kind of on pen and paper, it doesn't always match up. And part of that's because we have to assume things, we're all operating around an assumption of seal life. And if that seal is going to get replaced every 200 hours, that may violate some of our design principles in a sense, but it works for the customer, right? But if they want a 10-year life, all right, you maybe need to listen to us. So what we try to do is weigh the risks with the application and go, hey, I understand these aspects of the system. I understand how this is working. We're confident in this solution. Or I understand how it's working. There's a risk here. You should take a look at it. We always recommend testing and validating because there's so many different parameters that can be slightly different and have a huge impact. And, when you're talking about wanting to get the highest quality, highest reliability solution, it's can be a fine line between what works and what doesn't to hit those thresholds.
And personally, what do you find particularly interesting or satisfying about working in this kind of industry or this kind of genre?
Yeah, I mean, there's two big elements, with pumps and valves and fluid handling. It's I don't know, the unsung hero of the modern world. We can't live without this stuff, but we forget about it every day. So it's neat to be a part of that world and that industry. When it comes to seal design, I think what keeps me going is there's always a new challenge. There's always another stone to overturn. There's always something new to learn about a customer, about an industry. There's just a never-ending variety. I don't think I'll ever, know everything. There's always something more to learn, and that really engages me as an engineer.
All right, so before we wrap up, is there anything else you'd like to say or any final thoughts you'd like to leave us with?
No, just come back to sort of my advice. There's a lot of knowledge and expertise, and when you're working at the system level, it's very hard to have that granular detail of, oh, your surface finish is a little too rough. It's all you have to fix. So, um, you know, engage with the experts. It'll help you a lot, save you a lot of time and money.
Good advice in many aspects of life. Okay.
Mhm.
All right. Well, thank you so much for taking the time to talk with us. We really appreciate it.
Thank you for having me.
Huge thanks to Jeremy for taking the time to speak with us today about high pressure, high temperature sealing. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube channel to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.